Hi, so No Labs has released a report of a study that they conducted on their RFID technology, comparing it to Dexcom G6, which is an approved continuous glucose monitoring device. And in this video, we're going to look at the results of their study. But before we do that, we're also going to look at how continuous glucose monitors are being tested for accuracy, which I thought might be an interesting topic for us to learn a little bit more about. So hi, welcome back to the channel, everybody. Hope everybody's happy and healthy and doing well and getting out there to exercise. So yeah, you may recall that we discussed No Labs and their RFID technology back in November, I believe, when I put together a video about a number of different technologies and different companies. If you haven't seen it, I will put a link to that video in the description below. But in this video, we're going to focus on the results of No Labs tests, how well their device is performing. And first, though, we're going to talk a little about how those studies are conducted, and in particular, how they conducted their study. So starting with that, they conducted this with a single volunteer, which is very little, but the start. It was apparently a healthy female in the 25 to 35 year range, and they of course simultaneously collected data using the No Labs technology and the Dexcom G6 as a reference device. The Dexcom G6 is an FDA-approved non-invasive continuous glucose monitor. Well, actually, it's minimally invasive, to be technical about it. And it measures blood glucose in the interstitial fluid using a tiny needle. This is what it looks like, and there are plenty of videos by others on YouTube for those of you who are interested in learning more. So yes, a single volunteer is obviously not enough to validate anything or to get it approved by the FDA, but it is certainly a starting point. And so they conducted this test 11 times during a 16-day period, so on weekdays, not on weekends, with the subject sitting in a chair and being tested continuously for up to 4 hours per session, one session per day. In 10 of these sessions, they had the volunteer drink a glucose drink, the Acer Scientific Glucose Tolerance Test beverage, that's an mouthful, and 37.5 grams of it to be precise, 30 minutes into the test, with the test ending when the volunteer's blood glucose returned and stayed at a normal level for 30 minutes. So all in all, each of these sessions took somewhere between 3 and 4 hours. The 11th session was conducted without her drinking any glucose drink. And so in the course of these 11 sessions, they conducted what they call sweeps using their own technology, each sweep lasting about 7 seconds, which amounts to about 1,500 data sweeps for each 3-hour session. Data was collected using the No Labs device from both the left and the right arm simultaneously for the duration of the session, and they were using some 2,500 different radio frequencies ranging from 500 to 3,000 megahertz. The 11 sessions collected, of course, 22 data sets because it's 2 arms at a time, each with 3.5 million pieces of data. This is for the No Labs technology, and that's a lot of data. The Dexcom reference device connected to an iPhone app collected data every 5 minutes, and thus collected obviously significantly less data. Now, as you would expect, they obviously split the data into a training set and a testing set, which is the common procedure when you collect data to train your algorithms, with obviously the training data being used to train the AI algorithm and the testing data being used to by the trained algorithm to see how well it performs relative to the reference device. And so next, before we actually go over the results of their tests, let's talk a little bit about the standards that CGM devices and technologies are evaluated against, and in particular are evaluated against by the FDA, the Food and Drug Administration, which is of course the approval authority for medical devices and drugs in the US. So the FDA standard for personal use devices is that a new device has to produce values that are within 15% of the reference device's values 95% of the time, and within 20% of the reference device's values 99% of the time. And these studies must include at least 350 people with diabetes. There is a higher standard that the FDA has established for integrated devices, which is also more complex, where they have set a different set of criteria that have to be met within specified blood glucose ranges. We're not going to go over it because it's too complex, but just so that you know, it is there. And the more complex and higher standards for integrated devices are obviously a reflection of the risks that people with diabetes face at different levels of blood glucose, and ultimately this is reflected in what is called the surveillance error grid. So how well did the no-labs technology perform in this test? Well, quite frankly, not particularly well. Only 46% of its predicted values were within the 15% threshold of the reference device. This is what the reported data for the no-labs device looks like. Now, ideally, all the data points would be along the diagonal, showing the same value for the no-labs device and the reference device. That would reflect a perfect correlation between those two devices. Here, they are clearly not. They are too dispersed, and the data looks too much, quite frankly, like a ball, right? And if we look at the data for specific sessions, we can see that the blue line, which is the Dexcom reference device, and the green line, which is the predicted no-labs values, are not always in sync. In fact, sometimes they are very far apart. Now, the most annoying thing I find about this way of reporting results is that they don't report a correlation between the device that's being tested and the reference device. A correlation, of course, is the traditional and most commonsensical measure of sort of the correlation, the relationship between two devices and their data, and therefore the accuracy. Anyhow, so there we have it. This is only one set of data for one volunteer, performed over a limited period of time. It's a good start, but unfortunately the results leave something to be desired. Hopefully they will go to work and improve the algorithm, because at the end of the day, this is sort of a software algorithm issue. The RFID data is what it is, so it's really a question of how well they can fine-tune the analysis software to be more predictive. That said, kudos to them for sharing this data, although it doesn't look very well right now. That way we know sort of where they're at and how they're progressing. And with that, thank you for watching. Hope you enjoyed this video, found it interesting or something. Let us know in the comments below. And in the meantime, take good care, be well, and we'll talk to you soon. Bye-bye.